Here is a screencast on naming functional groups in organic compounds. So this first one, we have 1, 2, 3 carbons. The base name for 3 is propane. Ane because they're single bonds. Prop is 3, and we have 2 functional groups. We have a chloro and a fluoro. And let's alphabetize those. Chloro would go first, and fluoro would go second. So let's call that one the first carbon, the second carbon, the third carbon. So we get numbers and alphabetizing in fantastic order. So 1 dash chloro dash 3 dash fluoropropane. Let's look at this next one. I see 1 carbon, which is methane. Monkeys eat peeled bananas. Monkeys is methane. And we have, wow, chloro, fluoro, and fluoro. So that's called difluoro, and that's chloro. So chloro goes first, so it must be chloro dash, maybe a comma, I don't know, difluoromethane. I guess you could put 1, but there's no other place to put it. So I think that's just fine. This next one, I'm not sure if we cover this, but that group is commonly called benzene. It also is 1,3,5-cyclohexatriene. Benzene's much easier. So I'm just going to put the base name of benzene. I see 2 chloral groups. I would call that one 1 and that one 2. 1, 2 dash dichlorobenzene. I'm guessing that's a substance you don't want to eat. Probably kill you. This next one, might need to scroll just a wee bit. I see a cyclohexane. So that one's cyclohexane. I'm going to run out of room for writing this one. Cyclohexane. And we have a bromo and a fluoro. Let's alphabetize. What goes first? Betas, we'll call that one 1 and that one 2. 1 dash bromo dash 2 dash fluorocyclohexane. Now it looks like we're moving on to the alcohols. I see an alcohol here. Only 1 alcohol, and I see 1, 2, 3 carbons, so it's prop. Now alcohols have a suffix ending, and if you see an alcohol, it ends in OL. The older way of naming it, we would have called that one 1. So we can win with numbering would be 1 dash propanol. I think there may be a method out there now that says propan dash 1 dash all. I prefer the 1 propanol. It's a little easier to write. Let's look at this next one, number 6. It looks like a doozy. 1, 2, 3, 4, 5, 6 is hexane. They all look like single bonds. Hexane. I see nothing that's going to change my suffix ending. Oh my gosh. Or is that true? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It doesn't matter. I see lots of groups on here. I see an ethyl group. I see 1, 2, 3 chloral groups. I see a bromo group, and I see my friend iodo. So let's try this. We got the hexane, and I think we want to number it left to right. 1, 2, 3, 4, 5, 6. And we have to alphabetize. So that is ethyl. That's chloro. That's bromo. And that's iodo. What goes first? A, B, C. So bromo goes first. Bromo's on 2. I'm not going to be able to fit this all in here. Let's start up here. 2 bromo dash A, B, C. 1, 2, 3 chloros. So it's 2, 3, 3. 2, 3, 3. Tri. Remember we have to put that prefix for counting 3 because you have 3 numbers in there. So 2 bromo 2,3,3-trichloro, probably another dash. We haven't got them all off yet. We need A, B, C, D, E, ethyl. Ethyl's on 4-4-ethyl -1 iodohexane. So 2-bromo, 2,3,3-trichloro, 4-ethyl, 1 iodohexane. Hey, that's a mouthful. Let's look at this next one, number 7. It has 1, 2, 3, 4, 5. 5 is pent. I see a double bond in there. Oh my gosh, I see 2 double bonds. So I probably want to start counting from this end. Double bond trumps that functional group. 2, 3, 4, 5. So I see 1, 3 dash pentene, and I see this bromo group's on 5. So 5 dash bromo 1,3 pentene. Or I think the new school way is 5 bromo. Oh, I didn't actually say that right. It's pentadiene. That would be pentadiene. That's probably how you feel in this class, like you're dying. So 5 bromo penta 1,3 diene. Sometimes see this dying. I bet this feels like you, like you're dying. Terrible joke. Let's see if we can draw the structures for a couple of these. So number 8, 2-methyl 2-butanol. So I look at bute is 4, 1, 2, 3, 4. I see 2 and all, so 1, 2. I'll put an alcohol there. It can go on the top or the bottom. And on the second carbon, there's a methyl group. If I were to put my H's, I'd just like to draw happy dashes. And they're happy, I can tell, because they're nice and perky. Let's look at number 9. Number 9 is 2,3-dimethyl-2-hexanol. Hex is 6. 1, 2, 3, 4, 5, 6. So on the second carbon, there's a alcohol group. There's my alcohol group. 2,3-dimethyl. So there's 2 methyl groups. One's on the second carbon. One's on the third carbon. I like to draw the H3s in there. It makes me happy. It feels complete, like a nice set of brushed teeth. Let's look at this number 10. Scrolly matoli. New color. Propyl alcohol would also be the same as propanol. So prop is 3. 1, 2, 3. It doesn't say where the alcohol is, so it's on the first one, and you could draw it that way, or you could draw the alcohol on that end. For some reason it looks better on this end, but that's still 1. It looks a little weirder this way, but it's still 1, because it didn't say where. If it was in the middle, it would be 2 propyl alcohol. I hope this... Let's actually scroll through. I know I have some where you identify the functional groups. So if I were to ask you on a test to identify functional groups, which I do, there's these things called alcohols. I do ask you to write those and name the alcohols and also the ones with halides. But the other functional groups, I might just have you circle it and say what type of functional group it is. And we should name number 12. I see 1, 2, 3 is prop. I'm going to run out of room here. And there's 2 alcohols, so it's prop and diol. Di is 2 alcohols, and it's on the 1 and the 3. 1, 3 propandiol. This next one's totally weird. 1, 2, 3, 4. So I think I name it 1, 2, 3, 4. I think it's better that way. 1, 2, 4 dash butane. What is 3? Tri. Oh, totally weird. 1, 2, 4 butanediol. Tri means there's 3 alcohol groups. 1, 2, and 4. So let's look at this other stuff. Identify the functional group. So in this one, I see an oxygen bounded by 2 carbons. That's called an ether. It's a little bit like the ether bunny. 2 bunnies on either side of an oxygen. This one has an SH. They stink. That's a thiol. And thiol has an H in it. That's how you can remember the H. This next one has a C triple bond N, and it has this also. That part is called a nitrile. And this one, if you were to rewrite it, it's C double bond O and an OH, which is a carboxylic acid. Carboxylic acid. Let's look at these next ones. This next one, I think this is an amide. And this one might actually be an amine. It doesn't show the hydrogens on there. This next one, I believe, is something probably that smells good. It's an ester. Keep scrolling. We have some loaded compounds here. So most compounds have more than one functional group in it. That's what makes them a little more exciting. So this one is morphine. Morphine looks like it has an alcohol group. Looks like it has an ether. Looks like it has an alcohol group. It looks like it has an amine. Maybe that's where the ene comes from. Is that amine? I don't know that though. Caffeine, which is 1,3,7-trimethylxanthine, has lots of fun things. It has probably an amine, a ketone, another ketone. How exciting is that? Probably another amine, and it looks like maybe some stuff got cut out there. Caffeine. Woohoo! Well, I hope this little review on functional groups has helped you out.